In previous videos we learned how to apply certain rules when we want to evaluate the result of a logarithm. So let's say we had log to the basis of 10 of say 40, and we learned that we can do log 10 of 4 plus log 10 of 10, and we found that this one here, if we put that in a calculator, it would give us 0.60 to 2 decimals plus log 10 of 10, that would give us 1. I should do it like that, 1. So we would get as log 10 of 40, we would get 1.60. And here we applied the multiplication rule, because we said 40, we can write this as 4 times 10, and therefore we use that 4 here. The multiplication sign turns into a plus, and the 10 that becomes this one here. Okay, so that's all good. But what if we don't know this number here, if we have the whole thing in a slightly different format? Let's say we've got log 10 of, and now we've got our unknown number, our x here. An unknown number equals, let's say, 4. How do we find this x? What can we do to find x? Now, again, what we have done before is when we looked at something like 10 to the power of x equals, say, 1000, we said we want to apply the inverse mathematical operation of 10 to the x. And we applied, and I indicate that with these double slashes, we applied log 10 of, we took both sides, log 10, and we got log 10 of 10 to the x equals log 10 of 1000. And we said log 10 and 10 cancel each other out because they are the inverse operations. Now, what we actually see here, as I said, log 10 and 10 to the power are the inverse mathematical operations. They cancel each other out. So what we need to do in order to deal with this equation is we just simply apply what we just said. We use the inverse mathematical operation. How would that look? Log 10 of x equals 4. So what we do is we take both sides, 10, that's our base here, 10 to the power of, and I indicate it with this little roofy thing, because that is what the calculator will usually do. So what do we get? Let's not forget, we need to do that to both sides of the equation. So we get 10 to the power of log 10 of x equals 10 to the power of 4. And we know that log 10 and 10 to the power cancels out. So these two things eliminate each other, and we have left x equals 10 to the power of 4. And that is how we can deal with something like that. So we can also go for, let's say, log 10 of x equals 1.5. Let's do it like that. So what is x? Again, this time the value is not a whole number, so it might be slightly different then, but the principle is exactly the same. We take both sides to the power of, which I indicate here with these double slashes, and then 10 to the power of, and I write 10 to the power of log 10 of x equals 10 to the power of 1.5. And again we see 10 and log 10 cancel out. We have x, and that's left. X equals 10 to the power of 1.5, and we can try to calculate that. So let's head over to our calculator. So here we have 10, and we've got this symbol here, y to the power of x, and you see that is what I just wrote, 10 to the power of 1.5, and that gives us 31.622. So 31.62 roughly. There's obviously a little bit of rounding involved here. So what we can do, again, we use the inverse mathematical operations to eliminate our log. And as you can imagine, we can do that not just with log to the base of 10. So if we, for example, have instead of log 10 or log to the base of 10, if we have ln of x equals say 3.3, let's just make up a number. We remember ln, that stands for log to the base of e. So if we want to find x, all we need to do is really take both sides e to the power of. So because we use this e that we have here as the base, and take everything e to the power of. So we have e to the power of, and I now write, just to make it clear, log e of x equals e to the power of 3.3. And what we see again is e and log e, or ln, cancels out, and on the left hand side we have x equals e to the power of 3.3, and again we can put that in the calculator. So we have e, and the calculator very often it will show you this abbreviation of exp, which stands for exponent. It's a little bit yeah, okay, this is what e actually means. And we had e to the power of 3.3. So let's see what we get for that. So that gives us 27.11 as a result. 27.11 as a result. And of course we could, for example, get let's do log 10 of x equals, okay, let's go for a negative number. Let's see what happens if we've got a negative number. Let's say negative 0.5. So let's not worry too much about this negative thing here, because, well, this is just a number. So what do we need to do? Okay, we know that we have log 10, and we want to get rid of log 10, so the inverse mathematical operation, which would be 10 to the power of, so we have 10 to the power of log 10 of x equals 10 to the power of negative 0.5. And 10 and log 10 cancels out. So we've got x equals, and we said we can write 10 to a negative. If we've got a negative power here, this is basically what is left of a fraction line. So this would be 1 over 10 to the power of 0.5, and that would be the same as 1 over 10 to the power of 1/2, and that is just a sort of a refresher of exponents, if you like, equals 1 over the square root of 10. We can also extend that. It's just a little bit of fun. 1 over square root 10 times square root of 10 over square root of 10, and that would give us square root of 10 divided by 10, because square root of 10 times square root of 10 gives us 10. This was just a little bit of fun for me to apply some of the rules, but we had x equals 10 to the power of negative 0.5. Let's put that into the calculator. So we have, where is it? 10 to the power of negative 0.5. And we get 0.316 equals 0.316. Let's see if we got it right with this one here, just to see whether we got this correct. So we had 10 square root, oops, need to do it the other way around, square root 10 divided by 10, and that gives us exactly the same number, so we have done this right. Now, many calculators also have this built-in, and this is called an anti-log. And also this calculator has got it. So I can just put in the number negative 0.5 and then go for anti-log. No, I need to do it the other way around. I should know by now. So anti-log, and that very often is a log. And now I put in 0.5, close the bracket, and again I get my 0.316. So we can either do it with this 10 to the power of, or we can use with a lot of calculators a log. So this is how we can actually find out what this value here is. In general, if we've got log, say, a of b, and that is a number, let's call it c in this case, what we need to do is we take both sides of the equation a to the power of, and this is, let me write it like that, this is what we are looking for. Let's do it properly. Log a of x equals c, so we need to take both sides a to the power of, so we've got a to the power of log a of x equals a to the power of c, so a and log a cancel out, and we've got x left equals a to the power of c. And if you like, we can call this rule number 6. Although it's really just a reverse of what we have done before. So I hope this makes sense, and thank you very much for watching. In the next video we will go through a little bit more complex calculations, but again they are very simple. As long as we just simply stick to these rules that we've developed, it will not be any problem. Thank you very much and stay tuned.